Hello, this is lesson 10E and it's on samples and populations. And what we're going to do first is we're going to use this handout to talk about what those two things are. If you don't have this handout, you can download it on my PowerSchool website where you find my math videos. Okay, so let's go ahead and start in the first box here. The first box says, how are samples and populations related? So a sample is a small part of an entire group or population. Let me give you an example. So for example, we have 50 dentists chosen at random versus all the dentists in Orange County. The sample would be the 50 dentists chosen at random because it is a small part. And the population would be all the dentists in Orange County because that's the entire group. Pause the video if you need to copy what you see on your screen. Please pause now. Okay, so now we're going to take a look at two different types of samples. We have an unbiased sample versus a biased sample. So first let's focus on the unbiased sample. On the unbiased sample, the first bullet, I need you to write that it is representative of a population. So the sample represents the population we're looking at. For the second bullet, it is selected at random. So please write the word random right in there. For the third bullet, please write that it is large enough to provide accurate information. So you want a sample that is a good size amount. And for the last one, unbiased samples can be used to make valid conclusions about a population. Now pause the video if you need to copy any of this down before we continue. Please pause now. So now let's take a look at the next column where we have biased sample. So a biased sample is not representative of a population. The second bullet, one or more parts of the population are favored over others. For the last bullet, write should not be used to make predictions about populations because the predictions are not valid or not reasonable. So pause the video if you need to copy the entire section down correctly. Please pause now. Now let's take a look at example number 1. We're going to identify a population and a sample. So here it says you want to know the number of students in your classroom who do their homework right after school. You survey every third student who arrives in the classroom. Okay, so our population is the entire group that we are looking at, and we're going to underline that in red. So we are looking at the number of students in your classroom. Let's go ahead and underline students in your classroom. Okay, let me do a better job underlining. Okay, so that's our population, and we're going to write that on the first blank for part A. Okay, so now let's look at part B. What is the sample? So what is the small group that we're going to look at to be able to make, our conclusions about students in our classroom? So the small group that we're looking at is every third student who arrives in the classroom. So let's underline that. Every third student who arrives in the classroom. So that's what we're going to write for part B, every third student. Now we want to look at part C, and the question asks, is the sample biased, and explain. Okay, so we want unbiased samples. We don't want biased. So let's look at what an unbiased sample is and see if it fits all of those. All right, so for the first part, is our sample representative of a population? Well, yes, because we're looking at the students in our classroom and we're only surveying those students who come into the classroom. So yes, it represents the entire population. For the second bullet, is the sample selected at random? And the answer is yes again, because we're surveying every third student. It's not that we're only surveying those who are our friends in the classroom. Third bullet, is it large enough to provide accurate information? The answer is yes again, because you're doing a survey for every third student as opposed to maybe just 5 students. Okay, so in that case, it qualifies as an unbiased sample, and that's a good thing. So let's go ahead and write. It is unbiased because it represents the population and it's random. Please feel free to pause the video so you can copy what you see on your screen before we continue. Please pause now. Okay, let's take a look now at question 2, determining whether conclusions are valid. Now, we can only make valid conclusions when we are using unbiased samples. Okay, so let's look at this question. It says here that you want to know how the residents of your town feel about adding a new stop sign. Determine whether each conclusion is valid. So we want to make sure that they are using unbiased samples, okay? And for part A, it says you survey 25 chosen policemen and each support the new sign. So you conclude 100% of the residents of your town support the new sign. Okay, so first let's go ahead and underline the population. So the first sentence, it says you want to know how the residents of your town feel about adding a new stop sign. So our population is the residents of our town. So the residents, oops, I'm not using I don't mean to use that one. Let's underline it in red. Okay, the residents of our town. Okay, that is our population. Now let's look at the survey that in part A, or what our sample was. So our sample was our 25 chosen policemen. Okay, so remember, we're going to look up at that chart. Okay, the first bullet of that chart says an unbiased sample has to be representative of our population. And if you look, our sample here, policemen do not necessarily represent our residents of our town. Okay, so it looks like it's going to be biased because these policemen may not live in our town, or they may have a certain viewpoint about a stop sign. So now that we know it is not biased, now that we know that it is biased, then we're going to say, yeah, the conclusion's not valid because the sample doesn't represent the population. Okay, so a biased sample cannot make valid conclusions. Now let's look at part B. Part B says you survey 100 residents at random. 40 support the new sign, so you conclude 40% of the residents of your town support a new sign. Okay. So let's underline the sample here. The sample that we're looking on our survey is the 100 residents at random. Okay, so now let's see if that's an unbiased sample. Let's look up. Okay, is that sample representative of a population? Yes, it is, because we're only surveying residents. The second bullet, is it selected at random? Yes, it is. It states at random. Is it large enough to provide accurate information? Yes, it is. So we're going to stop there and we're going to say, yes, it's valid because it does represent our population and it is random. So on the last line, write what you see on your screen. It is valid because the sample is random and represents the population. Pause the video if you need to copy it down before you continue. Please pause now. Okay, last but not least, our third one is making predictions. Okay, so now we can use valid samples to help make predictions about our population. So in this one, it says you ask 75 randomly chosen students how many movies they watch each week. There are 1,200 students in the school. Predict the number of students in the school who watch 2 or more movies each week. Okay, so we're going to use a proportion. And first, let's circle the important information that we have in red. So we have 75 randomly chosen students. So let's go ahead and circle that. That is important. Okay. And then there are 1,200 students in our school. Okay, that is important. Predict the number of students who watch 2 or more movies each week. So let's underline that. And by the way, this is a good time to put a secret code word. The secret code word here, since it's talking about movies, is to write your favorite movie down below. You can just write it down below the pie graph. What is your favorite movie? Or just one of your favorites. It doesn't have to, you don't have to pick, say that's your only one, but it could be one of your favorites. Okay, so let's continue with the problem. So we're going to write a proportion. It says we're looking at how many watch 2 or more movies per week. And if you look at the circle graph, that's our 75 students. And it looks like 24 out of 75. Okay, we're going to write that as a proportion. Say they watch 2 or more movies a week. And then we're going to predict out of 1,200. Okay, so our next ratio is going to be 1,200 is going to be in the denominator, and we have x up on top. And then we solve this. Okay, so doing the cross products, we have 75x and then 24 times 1,200, and we get this. 75x equals 28,800. And then you're going to divide by 75. So I'm going to show here, divide by 75 on each side. Okay, and then we're going to get our answer. So our answer is x equals 384. And then we're going to write students. Sorry, I'm using the worst, what do you call these? Pens on here. It's not very good. Oops, I may have run into the movie name. Oh well. Okay, well, that's all for your notes. Thank you very much. Bye-bye.